Okay, so today's lesson should be pretty quick, except now we're taking what we learned from yesterday, so compound interest formula, and we're putting it kind of back into algebraic form how we did for the beginning of this unit. So we're on page 295 right now. So yesterday or today, depending on how the time went, we've learned about compound and simple interest. So we're saying that simple interest always has the same principal rate. Okay, so simple interest always grows at a linear rate. So you'll always earn the same amount of money every single year no matter what. Compound interest is where you actually gain a lot more. So if you get interest compounded annually, then every single year your initial investment will change because it'll take the interest that you've earned and add it to your initial investment. So every single year your initial investment will increase, so therefore you're gaining interest on interest. Okay, so this is our formula. Know this: A is always going to be the final amount. P will be your principal or initial investment. Your I represents the annual interest rate, and your N represents the number of years. Another difference between compound and simple interest is compound will give you the final. So compound, A is equal to your final amount. With simple, your I equals PRT. This is your simple interest formula. Your I is only your interest earned. So the biggest thing is simple. You have to go initial investment. So investment plus your interest to equal your final. Okay? So if you're switching between the two, just remember that your compound interest will give you your final amount. Your simple interest will only give you your interest earned, so you have to add that to your initial amount. So you just have to take that extra little step. Okay, borrowing money. When the amount of money is borrowed, interest is charged for the use of money for a certain fixed period of time. If the loan is paid off in one payment at the end of the loan period, the compound interest formula can be used. If repayments are made on a regular basis during the period of the loan, the compound interest formula cannot be used. Okay, so let's go into class example 2. So Travis borrows $2,000 from his parents and agrees to pay off the loan in one payment when he graduates. Interest is charged at 3.5% per annum, compounded annually. How much does he owe at the end of the second year? So let's just break down our compound interest formula. So we have A equals P times 1 plus I, all to the exponent N. A is at the end of the year. Travis is borrowing $2,000, so that'll be our A, our little a. And if the interest is being charged at 3.5%, so we have 3.5% plus 1, it'll be 1.035. And if we're talking about that at the end of the second year, our N will be 2. So our exponent will be 2 here. Since we have A equals all of this, we can just put it all into our calculator. So let's go 2,000 times 1.035 to the exponent 2. 2,142.45. So $2,142.45. So now they're asking, if you paid off the loan after 2 years, how much interest would have he paid? So then to find out the interest he's paid, you take the final amount and then you subtract the original amount. So it'll be 2142.45 minus you borrowed $2,000. So if you put this in your calculator, or you could just see, that'll be a difference of $142.45. So this is how much interest he has paid. Travis was not able to pay off the loan though after 2 years. And when he eventually paid off the loan, he paid $400 $458 in interest. So let's write an exponential equation whose solution gives the time period for the loan. Okay, so there's a couple things we have to do here. He pays $458 interest. So to find out the actual amount he's paying back, you take your initial investment, which is $2,000, plus your interest is $458. So how much he's actually paying is $2,000, 458 cents. Or sorry, $2,458. So this right here is equal to your A. So this is after he's paying. He still borrowed an initial $2,000. It's just your big A is changing here. So our new equation then is $2,458 is equal to 2,000, 1.035. Now we're looking for the n. Okay, we're looking for the number of years it will take them to solve this. So solve the equation algebraically to determine the time period for the loan. So to do this algebraically, it's like what we did Monday. Okay, so first off, we have to get just our exponential equation by itself. So we have 2,458 equals 2,000 times 1.035 to the n. I want to isolate 1.035 to the n. So to isolate that, divide both sides by 2,000. Okay, so on the left-hand side, I have 2,458 divided by 2,000 is equal to 1.035 all to the exponent n. Okay, so to solve these then, let's just add our logarithm. Oh, no, to solve this, let's change this into a logarithmic function. Okay, so to change this into a logarithmic function, you'll have log. You'll leave your base the same, which would be 1.035. Your argument will be 2,458 over 2,000. It's equal to n. You can put this right into your calculator. So to put in your calculator, you're going to go, I'm just going to clear this off, log of your argument. My argument is 2,458 divided by 2,000. So log of my argument, and you want to divide by your base now. So divide by log of 1.035. Close your bracket, press enter. So your n will be 5.99. If n is your number of years, so your n will be about 6 years. It'll take 6 years approximately to pay off an interest rate of $458. Okay, so let's talk about the compound interest formula. Compound interest formula on the previous page can be adapted for cases where the compounding does not occur annually. So the previous page, all we're doing is talking about annually. So now let's talk about when it's not annual. So A equals P times 1 plus I to the n. That's still the same. And so A still represents our final amount. P is still the initial principal. But the biggest change here is I represents the interest rate per compounding period. This will change for each question. And n represents the number of compounding periods. So I and your n work together here. They always have to be the same. Okay? Your compounding periods will, I'm not saying your I and your n will be the same, but your compounding periods will be the same. So if I'm talking about in years, your n will be your number of years, your I will be your interest rate per year. If I'm talking about number of months, n will be your number of months, I will be the interest rate per month. Okay, so it always has to be the same that way. It won't always represent annual because sometimes it'll be bi-weekly, sometimes it'll be yearly, sometimes it'll be monthly. It'll be, it really just depends on the question. Okay, so just be careful that way. So class example 3, if the annual rate of interest is 6% per year, state the interest rate per compounding period and the total number of compounding periods in each case. So if I have 6% per annum originally, if I'm compounding semi-annually for 5 years, so if I'm compounding semi-annually for 5 years, my interest rate is going to be 6% divided by 2, because if it's semi-annually, it'll be 2 per year. So it'll be 6% divided by 2. 6% divided by 2 is just 3%. Number of periods. So now I have 2 periods per year. I have 5 years. 5 years is given right in part A, so this will be 10. So my N will be 10, my I will be 3%. Okay? So let's look at monthly for 6 years. So if I'm talking about monthly, my interest rate will be 6%, and there's 12 months in a year. So 6% divided by 12, this is going to be 0.5%. If I'm talking about my N, I have how many months there are in a year. So there's 12 months in a year times 6 years. So 12 months in a year times 6 years, this is equal to 72. Okay? So your interest rate is always your interest rate per annum divided by your number of periods per year. And then your N is your number of periods per year times the number of years. If you want to write that down, that might be a good idea. So your I, interest rate, will be your interest rate, so rate per annum. Dash A is per annum, and you want to divide by your compounding period. I think that's what I want to say. Divide by compounding period, yeah. So if it's semi-annually, you're dividing by 2. If it's monthly, you're dividing by 12. If it's weekly, you're going to divide by 52. Okay? So it depends on how many per year. So monthly, there's 12 months in 1 year. So your N is going to be your compounding period. And you want to multiply by the number of years. Again, if it's semi-annually, there's 2 compounding periods in 1 year. And then if I am going for 5 years, it'll be 2 times 5. Okay. So I'm going to do this first one with you, and then you're going to pause it and see if you can do the rest on your own. Okay. So annually, number of compounding periods per year, I know it's 1. Annually, it's always 1. Number of, let's just read the question first. $1,000 is invested for 5 years at an annual interest rate of 6%. So now let's complete this table. Total number of compounding periods. If it's 5 years, your initial investment is $1,000. And your interest rate, 6%. Let's use those. So total number of compounding periods. If I am going annually for 5 years, I'm going to have 5 total compounding periods. Interest rate per compounding period. I'm just going to go 6% divided by 1, which would be 6%. So A equals your initial investment, so it'll be 1,000 times 1 plus your interest rate, 1.06. And then it'll be to the total number of compounding periods to the 5. So 1,000 times 1.06 all to the exponent 5. Enter. So your amount here, always round to the nearest hundredth, guys. Hundredths with money be $1,338.23. So $1,328.23. Okay, so pause it now and see if you can do the rest. Okay, so the biggest thing about this chart, so check your work, see if you got the same numbers. The biggest thing, the number of compounding periods per year, semi-annually is 2. Okay, so you're going to go 2 times the number of years, 2 times 5. Interest rate, your annual interest rate divided by your number of compounding periods, so 6 divided by 2 is 3%. Quarterly is always 4 times per year. 4 times 5 is 20 compounding periods in total. 6 divided by 4 is 1.5%. Okay. Monthly is 12. 12 times 5 years, 60 compounding periods in total. 6% divided by 12 is 0.5%. That is your interest rate per compounding period. To figure out all of your amounts, you would just put those straight into your calculator. Okay. Almost done, guys. So Christine invested $2,500 for 4 years, compounded semi-annually, received $843.26 interest. What was the annual rate of interest? Okay, so they give us A equals P equals I equals N equals. This is probably a really good idea to use all the time. Okay, so if they invested $2,500, that would be your initial investment, so that would be your P. If they received $843.26 in interest, you could find your final rate because you could just add that to your initial. So it would be 25, so your A would be 2,500 plus 843.26. Once you add those together, you usually get 3,343.26. Okay. Your I is what you're looking for. And your number of years, so you have 4 years compounded semi-annually. Semi-annually means times 2 times every single year. So your N will be 4 years times semi-annually. So your N will be equal to 8 here. So let's solve this. A equals P times 1 plus I, all to exponent N. We have our A, 3343.26 is equal to 2,500 1 plus I, we don't know our I, and our n is 8. Start out the same as any other equation, divide by 2,500. So I have 3,343.26 divided by 2,500 is equal to 1 plus I to exponent 8. Okay, so we have this exponent 8. To get rid of an exponent 8, you always want to do the opposite. So for example, on the top left, if I have x squared, if I want to get rid of the 2, I want to multiply, or just, sorry, raise the 2 exponent 1/2. So if I take the square root of x squared, this is equal to x. Same thing I want to do here. Okay, so I'm going to do this in red. So if I want to get rid of this exponent 8, I want to raise it to the exponent 1/8. When I do one side of the equation, I have to do the other. So when I raise that to the exponent 1/8, I get rid of the exponents on my right-hand side. I'm just going to keep going. I'll come this way. So I have 3,343.26 over 2,500. All to the exponent 1/8. This is equal to 1 plus I. That's all equal to 1 plus I. I can figure that on my calculator. Okay, so put in bracket 3,343.26 divided by 2,500, bracket to exponent, oh, sorry, not divide, to exponent, put this in brackets now, 1 divided by 8. So 3,343.26 divided by 2,500, all in brackets, to the exponent, bracket 1 divided by 8, bracket, enter. So I have 1.037, so this is equal to 1.037 is equal to 1 plus I. I can subtract 1 from both sides. So 0.037 is equal to I. Okay, the biggest thing about your I being different when it's semi-annually, your interest rate right here, so we could just say 3.7%. This is per compounding period, okay? How many compounding periods are there per year? There are 2, okay? So it's compounded semi-annually. You can't just stop the question here. So if it's compounded semi-annually, your initial I, what was the annual rate of interest? If it's talking about annual rate of interest, that means per year. So this is this 3.7% is per semi-annual compounding period. So you want to multiply this by 2. So you multiply it by 2, it'll be 7.4%. Okay, so this is a big question. Go over it a couple times if you have to. Andrea borrowed $7,500 from her parents to buy a new car. $7,500 borrowed, that's your initial. That is your P. The parents charge her an interest rate of 4% per annum per year, compounded quarterly. So 4% compounded quarterly, you want to go with 4% divided by 4 is equal to 1%. When she pays off the loan, she has to pay $785 in interest. So I know that will be added to my initial amount to equal my A. No, plus 785 equals 8,285. And we're looking for N. What was the length of the loan? Okay, so the length of the loan, we're going to answer in years. So same idea as the last one, okay? So let's just put this into our initial equation. So we have a equals p times 1 plus I to the n. Our a is 8285. Our p is 7500. 1 plus our I is 1%, which would be written as 0.01, all to the exponent n. I don't know what n is. So start this off the same, divide by 7500. So you have 8285 divided by 7500 is equal to 1.01 all to the exponent n. So now that you are looking for your exponent, make these into logarithms, okay? So I can just go log of my base. So log, my base is 1.01. My argument is 8285 over 7500 is equal to n. Put this right into your calculator. So log of your argument, so log of 8285 divided by 7500, close your bracket, divide by log of your base, be 1.01, enter. So your n is equal to, this isn't right, 82, oh, divided by log. Okay, I'm just saying. I forgot to put my logarithm. Insert, oh man. I'm sorry, start over. Log of 8285 divided by 7500. Close your brackets, divided by log of 1.01. And will be 10. So your n equals 10. This isn't answering it, okay? So we want the number of years. N is our number of compounding periods, our total number of compounding periods. So to figure out our number of years, so this would be 10 quarters. Because that's our compounding periods. We have 10 quarters. What we want to do is just divide by 4. So 10 divided by 4 is 2.5 years. Okay, just be really careful. Class example 5 and 6 are really good questions to figure out when you're looking for I, what to do. When you're looking for n, what to do. When you're looking for your interest rate, get rid of that exponent by multiplying by the reciprocal. Then to find your annual interest rate, multiply by your yearly compounding period. When you're looking for your number of years, okay, same idea to start off with. Then set it equal to the logarithm. And then divide by your number of compounding periods, okay? So there's a couple things you're going to have to work on. So do a lot of questions. So number 8 to 20 or 8 to 16 are good. Ms. Nichols will tell you which one she wants you to work on. If you are all done, you can just keep going and get all caught up on lessons 1 to 7. Okay? Good luck, guys.